problem 1138 out of Shigley. It might be numbered differently in the 11th edition, but I think this is 9th and 10th edition. This is what the number was. We want to estimate the remaining life and revolutions of an O2 30 millimeter angular contact ball bearing already subjected to 2,000 revolutions with a radial load of 18 kilonewtons, if it is now to be subjected to a load of 30 kilonewtons, right? So this isn't really all that much different from the other example. I think I wrote down that I wanted people to do this in class, to try it themselves, see if they could work it through the thing. So if we go to a table 11.2 in the book and look this up for the 30 millimeter for the angular contact bearing, we should get it's 20.3 kilonewtons. 20.3 kilonewtons. For this bearing right here. And that life, expected life that's based on is 1E6, or 1 million, right? So we take that idea of the C10 is this desired times the desired divided by the rated to the 1 over A. And we say at 18 kilonewtons, 20.3, 18, L1, 1E6, 1/3, L1, 1.434 E6. And then we say at 30, we'll call that L2. Get 3.098 E5. These are, we could say these revs or cycles, whatever we want to call them. So we take our L1, which is 20,000, a little L1, big L1, plus little L2 over big L2. We're going to say that's going to be equal 1. So we say 200,000 over 1.434 E6 L2 over 3.098 E5. And we get little L2 is 2.667 E5, or I might write it out here that we're going to predict the thing is going to live to 267,000 revs. We'll call them revs. Because they call them revs, right? They call them revolutions. I said, what is, okay, yeah. Estimate the remaining life in revolutions. So we call them revolutions. Kind of like very similar to the other one. I don't know. Maybe it's too similar. It is similar. It's almost identical. It's kind of pointless. I don't know. Very fast too.